Hello everyone. Today I'll be conducting a hypothesis test using one sample t-test in R. The null hypothesis is the average income per capita in XYZ country is 10,000. An XYZ country is just a given name for the sake of this experiment. Alternative hypothesis is that the average income per capita in XYZ country is not equal to 10,000. It's either above or below. The type of test that we will do today is a one sample t-test. It's going to be a two-tails test because we do not pre-specify it whether either we're looking for above or below. We are looking at both of them. In other words, if you look at this distribution, if it's above the distribution, if it's below the distribution, that's where they're going to um, uh, exceed. The level of significance or acceptance rejection criteria is 0.05. In other words, the p-value has to be below 0.05 in order for us to be able to reject the null hypothesis. I'm going to do this in R. Let's go to R. So to begin with, I imported the data set. It's called survey data. It's a dummy data that I produced just for the sake of this training. And so I pre-selected the variable so we don't have to write the field name each time, the variable name each time we want to call in a field name. Something very important is that t-tests, we're comparing the means of one distribution against another one. So we have to be sure that the data that we have is not highly significantly skewed. So for that reason, we need to look at the distribution of the histogram to see if the distribution is not highly skewed. We can also do this by looking at the box plot, and evidently there is no, excuse me, evidently there are no outliers here. So this distribution is not very abnormal. Next, I'm going to we're going to write the script for the t-test. So that will be t-test, and the name of the field is per capita income, and mu is the average that's accepted. In other words, the average of the null hypothesis, which is this average here, 10,000. So we put the mu. That's a statistical parametric name for average mu. So you put 10,000 here, and then confidence level. We also need to put the the alternative for or either we want a two-sided test or one-sided test. So remember that R by default accepts performs a two-sided test. So even if we don't put this by default, it will accept it as two-sided since so we won't add that part of the script in there. The last part will be to put the confidence interval level. So the confidence since this is a socioeconomic related survey, we will be looking at a confidence level of 0.95 or the reverse is 0.05 for the p-value. So I'm going to go ahead and run this script. There you go. This is the answer. As you can see, the T is 4.5567. The good thing is that R, uh, unlike Excel, provides you the p-value, so you don't have to go to the T distribution table to find the value. So we won't be using the T distribution table. Instead, we will be looking at the p-value. So the degree of freedom of 52, a p-value that's below 0.005, and it's to the infinity. So the true mean and the alternative hypothesis statement is that true mean is not equal to 10,000. So in other words, we can reject the null hypothesis and accept the alternative hypothesis that the income per capita of that XYZ country is not 10,000. The mean of X, or the mean or the average of our survey data, 16,258, and with 95% confidence interval, we could this can below point will be 13,502, and the upper point will be 19,014. So we can pretty much, this is the part of the test result that we need. We can go to our file and we can use this to write our conclusion, in which case it would be um, the one sample t-test. We can put the p-value here, p-value below 0.05. Well, first we can put the t-test critical score. T-test equals 4.55. We can round it up to 4.56, and p-value below 0.05 revealed that the uh, income per capita in XYZ country is not 10,000. The test further indicates that that the difference in average, again, this is not standard, so any way that you deem as necessary, you can write it, and everybody have their own writing style. But my suggestion would be to always make sure you add the statistical indicators in your report. So the test for indicates that the difference between let me see if I don't have the difference in the mean, but I could say something as the mean, the average income per capita in XYZ country is statistically different from the average income reported by so your null hypothesis, where did it come from? Did it come from people accepting it as a fact, or some agency has reported it or has established it? So you can put it here, reported by the Department of Economics. So this will be the end of this video.